G'day team, welcome back to yet again another video, and today we are going to look at increase and decreasing functions and how our derivatives can apply here. So I've got four functions here. Now increasing means if I look from left to right, I can see my y value goes up. So I could say this one's increasing because as I move left to right, my y value increases. This one here I would say is decreasing because as I move to the right, my value for y is decreasing. This one here I would say is increasing because it moves up all the way. Now this one here I would say is decreasing to x equals 3 and then increasing to the right of x equals 3. Okay, so there can be functions with different intervals of increasing and decreasing. That's going to be the first focus of this video. So in a nice definition way of what I just said, my function f of x is increasing if f of a is less than or equal to f of b. And this is for x of x equals a being less than or equal to x equals b. So as I move left to right, my y value increases. Okay, f of x is decreasing if the opposite is true. So having a look at this graph here, where is it increasing and where is it decreasing? Now, if I move left to right, I would say it's decreasing until -2. So we always look at the x's, so -2. Now it's increasing to +3, so here, and then it decreases for as long as that little arrow goes on. So there's two little intervals of decreasing and one big interval of increasing. So we said it was increasing between -2 and 3. So -2 is my lower limit, x, and then 3 is my upper limit. So we're saying that this function increases from -2 to 3. Now it decreases when x is less than or equal to -2. And it also decreases when x is bigger than 3. So x is greater than or equal to 3. And you can sort of see we've got the opposite here. Okay, so that's going to be our focus for the first bit. So f of x is increasing if the derivative at that point is greater than or equal to 0. So it's a positive gradient, so it looks like this. F of x is decreasing if f dash of x is less than or equal to 0. So it's negative and it's decreasing, looks like this. It's a negative gradient. At my maximum and minimums, I've actually got my derivative is equal to 0. Okay, so that is a key point to look at there. What we can call that is a turning point, but it pretty much just represents where my function changes from increasing to decreasing. And now that's going to be a key point for us. So what we want to do is create a sign diagram. Now I have a video of sign diagrams a little while back, slightly different to what we're doing now. Those sign diagrams were looking at whether the function was above or below the x-axis. We're now going to look at sign diagrams as to see whether the gradient is positive or negative, or in turn my function is increasing or decreasing. So I'm going to run you through the process with an example. We're going to then do 2 examples together from scratch. So it's going to be a slightly longer video, but it's good to see those examples. So f of x equals 3x squared plus 2x. Now, because we're looking at increasing, decreasing functions, I want to have a look at the gradient, which means I want to look at the derivative. So I take the derivative of this function by putting the 2 out the front and multiply by the 3 to become 6. The 2 drops by 1, and then this x cancels off to be 2. So I've got my derivative here. Now up here I said this turning point, this key point here is when f dash of x equals 0. So I want to set my derivative to equal 0. So f dash of x equals 0 when 6x plus 2 equals 0. So my derivative here. Now let's solve this equation for x. I subtract 2 from both sides and then I divide through by 6 to get -1/3. This x solution here is my key point that I want to use on my sign diagram here. So -1/3. Now thinking back to sign diagrams, this process is the same. I want to choose a number smaller than this, which is -1, and a number bigger, which I chose 0. I want to substitute these values into my derivative to see whether they're positive or negative. Now, if I put -1 in here, I've got -6 plus 2, which is -4. So because that's negative, I put a negative there. If I put 0 in here, I get +2, so that's positive. Now, that means, because of my negative, it's decreasing to the left of -1/3, and it's because of this plus, it's increasing to the right of -1/3. So, I want to write the interval that it is increasing and decreasing. So for my function f of x, it's increasing for x greater than or equal to -1/3, because the plus is on the right, and it's decreasing for x less than or equal to -1/3. So that's the process we're going to use. I'm now going to go through two examples, two very different examples, so they're good to write down as well. So find where the function f of x equals 4x cubed minus 2x squared is increasing / decreasing. As soon as you see a question written like this, we know we're doing sign diagram. So I want to first and foremost find my derivative. Now the 3 comes out the front and multiplies by the 4, and we drop the power by 1, so I get 12x squared. And my second term, I get minus 4x. Now, we want to set this to be equal to 0. So that means I want 12x squared minus 4x equals 0. You can use your calculator to factorize this. I'm just going to do it by hand for now just to make it a bit quicker. So I'm going to pull an x out the front. I'm left with 12x take 4. We can even take out a factor of 4. So let's go 3x take 1 and take out a 4 there. So that equals 0. Now I can use the null factor law. The x that makes that equal 0 is 0, and the x that makes this 0 is 1/3. So they're my two values I put on my sign diagram. So I've got 0 and I've got 1/3. Now -1 smaller than 0. We'll go a quarter in there, and then we'll go 1 in there. Now these values I want to put back into my derivative. So let's put them into here. If I put -1 in here, that's positive, overall positive. If I put a quarter, this becomes 1/16. So this is 3/4 minus 1 is a negative. Then if I put 1 in there, I get a positive. So that means I've got 2 increasing portions and I've got 1 decreasing interval as well. So for f of x equals 4x cubed take 2x squared, I'm increasing, decreasing intervals. Now increasing, I've got x less than or equal to 0 and x greater than or equal to 1/3. So that represents this left side and this right side. Then I've got to do my decreasing, which is in between the two. So 0 is less than or equal to x, which is less than or equal to 1/3. Okay, so that's another pretty simple example, a bit like the one above. So let's do a slightly trickier example. So find whether function f of x equals x plus 4nx is increasing or decreasing. So we know we're going to have to do sign diagrams, and we know we're going to have to do the derivative. At the moment, my function isn't set up for me to do the derivative because there's an x in the denominator. So let's set our function so we can. So f of x equals x plus 4x to the minus 1. Okay, so we bring that x to the top. Now we can find my derivative, which is f dash of x. So I got 1 minus 4x to the power -2, or in other words, 1 minus 4 on x squared. Now, in this case, I want to put these two terms together, and we're going to do that by cross multiplication. So 1 is divided by 1. So I want to multiply top left to bottom right. So 1 times x squared, it's x squared. Then I've got 4 times 1, which is 4, all over 1 times x squared, which is x squared. Now you're probably wondering, why would I do that? But now that I have it set like this, it's gonna sort of show a really key point. Now, when I have a fraction like this, I want to solve the top to be equal to 0. This gives me my turning points. And I also want to solve the bottom equal to 0. Because if I make the bottom equal to 0, that function would be undefined. So that means I get an asymptote, which is a really key feature of this graph here. Okay, so we've got to solve for the top and the bottom equal to 0. So on the top, I've got x squared take 4 equals 0. Now you can do this two ways. It's a difference of two squares, or you could add 4 to both sides, take the square root plus or minus the square root of 4. Either way, it doesn't really matter. We're going to get x equals plus or minus 2. And to solve x squared equals 0, x has to just be 0. So that means when I do my sign diagram up here, I actually have 3 points of interest. I have -2 and 2, but then I have an asymptote at 0. So we've got to denote our asymptote with a dotted line. We still do everything else exactly the same. So -3, -1, +1, +3. Pick some numbers, put them into my derivative into here. If I put -3 in here, positive, take 4, that's a positive over a positive. That's positive. If I put -1 in, that's -3 on top over +1, that's a negative. If I put +1, I've got a negative, and if I put +3, I've got a positive. So for my function f of x equals, and that was x plus 4 on x, I've got increasing, I've got decreasing intervals. Now, I'm increasing when x is to the left of -2. So that means when x is less than or equal to -2. And I also have it increasing when x is bigger than +2. Now, it's decreasing between this whole region here, but it cannot equal 0. So I've got to put that condition on it too. So -2 is less than or equal to x, which is less than or equal to 2, but it we'll denote it with a comma. X cannot equal 0. Okay, so that asymptote means my function cannot equal that point. There's some good examples there. Hopefully you can go through and apply this to some different types of functions. Hopefully you get this down because we're going to extend on this idea in the next video. We'll see you then.